All right, welcome, ladies and gentlemen. We are on lesson 4.4, solving two-step inequalities. Our goal, the objective, I can, or I will, I like that one, solve multi-step inequalities, and then we're also going to throw in a few real-life problems at the very end. Kind of like we mentioned with the, brother going on the airplane on a vacation. Ooh, vacation sounds very nice right now. Getting closer to Thanksgiving. That's good. All right, so we're going to go ahead and remember that we're going to still be using our beginning steps. We're going to start with the addition subtraction, so we need to use those inverse operations. And then we're going to go to the multiplication division for our inverse operations. And then this is the sticking point for some of you. If you multiply or divide by a negative, you do need to reverse that inequality. So it's actually very similar to what we did going over our Chapter 3 test skills or Chapter 3 test problems, is making sure we still have those skills from Chapter 3, solving equations, because they do apply to solving inequalities. And then we'll quickly look at the graph again for some of them. All right, so we're going to solve, then graph. So as I have the problem here, my goal again is to start or is to get y isolated, which means alone. And I'm going to start with the addition subtraction idea. So I'm going to look at that subtract 7. And if you remember, the inverse operation is to add 7 both sides. In doing so, I get a nice basic 12. And then my last step, of course, is to divide. Just getting ourselves warmed up because, again, it's really just the negatives that throw students off in Chapter 4. So if we practice nice with the positives, then we can be ready for the negatives. So y is greater than 2. And if you remember, when we graph for the number line, let me see if I can get my pen ready, is we're going to go ahead and just do some basic numbers. So we're going to put that number 2 in the middle. And then I really just want a number on the left and right. You could always put more numbers, but this is the minimum. So just basic counting, 1, 2, 3. Open, make it abnormally large, and then either the trick or the words. Remember, the words would be is greater than. And we know that 3 is greater than 2, so that's going to be shading to the right. So again, just fill it in. You can use your highlighter, whatever you need to do there. Again, it just needs to look like it's going to the right with an arrow, though, because remember, it keeps going to the right. All right, solve, and then graph the solution again. Ooh, we got a fraction there. Now, I'm not going to go ahead and put a different number there. We're just going to use the basic number as given to us. So, starting with our addition subtraction, I'm going to subtract 4 from both sides. Gives me a nice 7. I'm actually going to put a 1 in front of the x, though. Remember, that's allowed for work, not the answer, though. All right, so here, please pay close attention. I have a fraction, which means division, so I'm going to use multiplication. So I'm going to multiply both sides by the reciprocal. So I'm actually going to do negative 5 over 1. All right, so this is where some students are getting confused. I am multiplying by negative 5. So in the parentheses, you see the negative 5. I am actively multiplying by a negative number. Therefore, I must reverse the inequality sign. So instead of greater than, the words now would be is less than, which means it would affect your graph. Not only does it affect the actual statement, but it also affects the graph because the shading would be going to the left. The negatives, again, I'm counting backwards, so negative 34, negative 35, negative 36. We have a closed dot, make it bigger than normal. And again, shading to the left. Again, it doesn't have to be perfect, just shaded. Looks like an arrow going to the left. But again, I multiplied by a negative, so that's the key there. All right, let's be careful on this one because the order is just a little bit different, but the variable is on the side that I wanted. Remember in the past, maybe you want to put a little question mark here. Is the variable on the left side. And we want it on the left side, if you remember, because that's what we did in chapter 3 with the solving, but it also makes the shading, the graphing just a little bit easier. All right, let's subtract 4. Be careful here. Negative 3. D is less than or equal to negative 15. Right, on this one here, I'm going to divide. What am I going to divide by? I'm going to divide by negative 3. Since I am dividing by a negative, meaning at the denominator, we see a negative sign. That tells me that I need to reverse my inequality sign. Oh, that's silly. Just realized all the little steps would show up. Silly, Mr. Murillo. It's all messy now. So I'm going to actually go back. So negative divided by negative is a positive. 15 divided by 3 is 5. So I'm going to proceed to get just that nice number line. Sorry about the coloring there. D is greater than or equal to 5. Again, you can back the video up if you need to see it a little bit clearer. All right, so our important number is 5. So 4, 5, 6. Solid dot, because it has the equal part underneath it, shading to the right. 6 is greater than or equal to 5, and 6 is on the right side. Silly, Mr. Murillo. All right. Solve, then state the reasoning for each step. Now, we wouldn't normally do this on our actual test, but you might do it if we see it on the next practice test, the state test, all that stuff. Maybe you'll see it next year. So what is that first step called? Let me give you a moment to think about it. 5 more seconds. Yeah, we actually saw it on our chapter 3 test. So again, that is called our distributive property. Then I would continue on. So I'm going to work with the 2x or the subtract 10. Which one? I'm going to work with the subtract 10. Again, it's called inverse operations. Add 10 both sides. Sometimes it's called the addition property of inequality because I'm adding to 10 to both sides. Our inverse operation is just that general term of, hey, what am I going to do to solve it? Oh yeah, I'm going to do add 10. All right, then my next step is obviously divide by 2. That is our division property of inequality. So that simplify step, I don't even know if we really need that because 1 plus 10 is 11. That's kind of an automatic, but that's what that simplify was. All right, I'm dividing by 2, and if you notice, it's not going to give me a nice integer answer. In 8th grade, we would leave it as 11 over 2, but in 7th grade, we would write it as 5.5, or you could even use your mixed number, 5.5. Now, the reason the decimal might be more helpful for some students is because in order to actually graph it, if you remember, we would have 5, 6, maybe 7, and 4. So on our fractions or decimal, we're going to put a few more points. 5.5 is in the middle of 5 and 6. According to this, it is a closed dot. And I am going to shade to the left because less than 5.5, well, 5, 4, 3, all the way to the negative side again is less than 5.5. It's also equal to, which is why it's a closed solid dot. Which again means it includes that specific number in the solution set. Beautiful. All right, let me give you a small head start on this one, and then we'll get to our real life problems. You know what? Pause the video and try it. Welcome back. If you paused your video, negative 4. You know what? It's just going to go. Silly, Mr. Murillo. Again, negative 4 times n is negative 4n. Negative 4 times negative 10 is positive 40. Again, that is called our distributive property. This time, instead of adding 40, I'm going to subtract 40 on both sides. So that's going to give me negative 4n is less than negative 8. I'm still going to divide again. And since I'm dividing, though, we got to be very careful to reverse the inequality sign. So that would be n is greater than 2. And then quick graph. Again, if I divide by 3, 4, 5, 6, then I'm good. I don't have to do anything with the inequality sign. But if I divide by a negative, I must reverse it. Same thing with multiplication. All right, open dot, shading to the right. Excuse me, need some more Pepsi Cola. Greater than 2, 3 is greater than 2, but remember, it also includes the fractions, decimals, roots, everything like that. All right, 2-word problems. Mariella's parents have budgeted at most $575 for her quinceañera celebration. The cost of the party room is $75. How much can the family spend per guest on food if each of the 40 guests receives a $5 favor? Ooh, very nice, very nice. So let's see here. We've got 575, that's the total at most, which means they cannot go or spend more than 575. So remember, that's going to be helpful for our inequality. The cost of the party room is $75. Okay. 40 guests receive a $5 favor. So let's see. I guess our food is our unknown, right? Let's see. Let's see. At most. Okay, per guest. That's kind of the helpful information. All right, X is going to be spending on food. Party room we know is $75 plus food times 40 people, because remember, it's really how you plan parties. They determine how much it costs per person. The favor is also, they get, their parting gift. Yeah, they can't spend more than $575, so it has to be less than $575. So the party room is $75. The food is $40, and then each person is going to be really X plus 5, because each person's going to get food and a favor. And then it's less than or equal to $575. Man, that makes me want some food now. Now, you never get this. My very first year teaching, I had one of my students who was a little bit older. She actually turned 15 in 8th grade, so that means she was held back. But she invited all of her teachers to her quinceañera, and it was very fun. So my wife and I went, her other teachers went, and we had a great time. It was very nice of that student to do that. Some of you are like, oh, I would never invite Mr. Murillo to my party. Silly kids, you don't know what you're missing out. All right, 75 plus, distributed property, 40x plus 200. So that means if I combine like terms, it's going to be 275. Now you have a nice 2-step inequality to solve. All right, so go ahead and do that. Remember, we're going to do our inverse operations. We're going to start with the 275, not the 40. So it gives me 40x is less than or equal to 300. I divide by 40. If you want to use the little trick, you can cross off the zeros at the back. So I'm going to do that real quick, because it's kind of like you're mentally dividing by 10. So you really just have to do 30 divided by 4. So x is less than or equal to $7.50. That means each person can essentially get $7.50 worth of food. So a catering company would be able to tell you if they can actually meet that. Sometimes certain parties, it might be $10 per guest, but again, $7.50, that might be doable. Again, I'm thinking of nice food, especially at a quinceañera. Quinceañera! I'm helping my son with Spanish. He's a freshman. I like overpronouncing things. But yeah, quinceañera, the one I went to, they had nice tacos and all these other great traditional food items. All right. Ooh, another party. Man, makes us want to have a party, huh? Not yet, not yet. The Carleton Company budgeted $1,825 for a banquet. So this is a company, a little bit more money than a family. Okay. The cost for the facility is $225. That's actually probably a steal. It's probably more than that. How much can the company spend per guest on food if there is a $3 charge per guest for linens and there are 80 guests coming to the banquet? So instead of getting a party favor, they get to use like fancy napkins. I don't think they get to take home the fancy napkins though. But it's a similar idea. We're trying to find out, again, food is the unknown. All right, so good information going through here. So let's see. X, again, is food. Facility, $225, right? Plus 80 people are getting food and 80 people are getting fancy napkins to use. Don't get to keep it. And they've budgeted $18.25, which means they can go up to that, but every company would love to come in under, which means not spending the full amount. So as we set it up, again, it's $225 for the facility plus 80 guests who are going to have food and fancy napkins. Maybe you've been to a fancy restaurant before. It actually does make you feel pretty cool. Like, ooh, look at this fancy napkin. All right, going to use my distributive property again and then combine like terms. $225 plus $240. Remember, if I'm going a little too fast, you can pause the video, back it up, whatever you need to. Adding it up, you get $465. You can put the 80x in the front of $465, but it really doesn't matter. Because again, I'm not going to work with the 80x yet. I'm going to work the $465. So let's subtract $465 from both sides. Again, this little vertical segment right here is not really needed, but if you want to use it, you can. When I divide, remember, I can use the little trick if you'd like to. You can cross off the 0 at the end, only at the end, because again, it's like dividing by 10. 80 divided by 10 is just 8. 1360 divided by 10 is 136. I just cross off the zeros. All right, doing some quick division. I know that x is less than or equal to, $17 per guest. Maybe that's going to be like, well, not, I wouldn't say lobster at that price, but maybe that's fancier chicken or fish, maybe lower quality steak. I know that sounds weird, but sometimes there's a really good quality steak. But at $17 per person, probably not so much. But still pretty good. What do you know? We are done already. Fantastic. So again, I will join you for some homework help. All right, be awesome.